All right, this video is going to go through the chapter 6 warm-ups. So in 6.1, you talked about the angle bisectors and the perpendicular bisectors. For number 1, this segment is, or ray is the perpendicular bisector because it's perpendicular and congruent. And any point on this would be equidistant from the endpoints of that segment. So 3x plus 1 would equal 4x minus 7. Subtract the 3x. And add the 7. X is 8, but it's looking for AB. So we got to take that and plug it back in. 3 times 8 plus 1, 24 plus 1, which is 25. Okay, 2, again, perpendicular bisector, which means these are congruent. 5x plus 7 equals 7x. Subtract this 5x, 7 equals 2x, and divide by 2. And x equals 7 over 2. It wants you to find AB, so I'm going to plug that back in. And I get 49 over 2, which you can leave, or you can make 24.5. All right, now we're dealing with the angle bisectors. So the angle bisector is, well, if the sides are equidistant from a point on the angle, and I know it because of the right angles, and these are marked, then it lies on the angle bisector. So if this is the angle bisector, these two are congruent. 3x plus 4 would equal 4x minus 8. Subtract the 3x. 4 equals x minus 8. Add the 8. And x equals 12. And this time, we're finding the value of x. So we're done. Four says these are congruent to each other and these are congruent to each other, which means that this is your angle bisector. And if these are congruent, then that shows the distance, which means these angles would be a right angle. And 4x plus 10 would equal 90 degrees. 4x would equal 80, and x would equal 20. All right, 6.2. In this diagram, the perpendicular bisectors of ABC meet at point G. What's point G called? And then find EC and GC. So the point of concurrency for perpendicular bisectors is the circumcenter. And it meets at a point that's equidistant from the vertices. So these are all congruent. If it wants you to find EC, I also know these are congruent, so this would be 5, and EC would be 10. And it wants you to find GC, all of the parts that we highlighted before in green, or the ones connecting the center to the vertex, are congruent, so GC is 7. 2 says in this diagram, the angle bisectors of XYZ meet at point D. What is D called? This is called the in-center, point of concurrency of the angle bisectors. And it says AD is 10. So this time, the angle bisectors, which are the longer ones here, here, and here, meet at that in-center, and from the in-center to the sides, which means all those little right angles, are congruent. So if AD is 10, all of these are 10. And it wants you to find DB, which is also 10. All right, 6.3. Now we're talking about the centroid, which is where the medians meet. And this is that 2/3 theorem. So if BG is 9, and it wants you to find BF, this is the 2/3. So the BG is 2/3. Cut that in half. That's 4.5. That'd be the GF part. And so the whole thing would be 13.5. All right. The next one says BD is 12. So let me erase this part off. BD is 12. Find AD. Because it's the centroid, I know this is the median, and if it's the median, it cuts it into two congruent parts. So AD would also be 12. And last up, CD is 27. And it wants you to find GC. So GC is the 2/3 part. I can either do 27 times 2/3, or I can take 27 divided by 3 and then double it. It's the same thing. So 3 goes into 27 9 times. 9 times 2 is 18. Number 4, it says find the centroid of ABC. So we can go the long way and we can find the midpoint of each side and then connect them. So like I would accurately find the midpoint by adding them and dividing by 2. Or the shortcut for the centroid is to find the vertices and divide each by 3. So if this is -1, -2, this is -3, 1. This is 1, 1, 2, 3, 4, 5, 5. And this is 1, 2, 3, 4, 5, -3. I can add all the x's, divide by 3, add all the y's, and divide by 3. So I get -2 plus 5, which is 3 over 3, and that's 1. And I get 6 minus 3, which is 3 over 3, and that's also 1. If you go back to where our approximate answer was, it also makes sense that that would be 1, 1. Number 5 says, which type of triangle has an orthocenter on the triangle? We know that orthocenter is your in, on, and out, and the on happens on a right triangle. All right, 6-4 is dealing with the mid-segments. So this one says, use the figure to answer questions 1 through 4. If UV is 14, find RT, which would be double it, so 28. 2 says, if ST, which is this whole side, is 20, find UV, that's half of it, so that's 10. The next one says, if the perimeter of RST is 68, find the perimeter of UVW, which would be 1/2 of it. Divide that by 2, and I get 34. And if VW is 2x minus 4, and RS is 3x minus 3, what's VW? So we have to solve for x. I would say that 3x minus 3 equals 2 times 2x minus 4. Subtract that 3x. Add the 8. X is 5, and it wants VW. So I'm going to take the 2 times the 5 minus 4. And VW is 6. 6-5 in exercises 1 and 2, list the angle or sides in order from least to greatest. So we already know the angles in 1, which means we're going to do the sides. Least to greatest. So smallest would be AB. Middle would be BC. Last would be AC. Go to 2. Now we have the sides, we want the angles. Smallest angle, R. Middle, T. Last, S. Number 3 says to tell whether the side lengths can form a triangle. So remember here, we're going to add the 2 smaller ones and make sure to be bigger than the third. 35 plus 18 is 53, which is going to be bigger than 37. So this is yes. And then for 4, 3 plus 3 is 6, not bigger than 6. So this is a no. Number 5 says Jeremy wants to build a triangular toy using sticks. He has one stick that's 12 inches and another that's 10. What are the possible lengths of the third side? So remember, for these, we say that it has to be greater than the difference. So it needs to be greater than 2, but less than the sum, which would be 22. All right, in 6.6, you're dealing with the hinge theorem and the hinge theorem converse. Number 1 shows that this side is equal to this side, this to this, and it wants to know if KL is less than or greater than or equal to KP. Since KL is opposite 75 and KP is opposite 80, KL would be less than NP. In number 2, you've got the 28s on the outside, the reflexive side shared between them, and then the third side, this one's 12, this one's 22. So this should be angle. The measure of angle 1, which is opposite the 12, would be smaller than the measure of angle 2, which is opposite the 22.